Hello everyone. In the previous video we saw all the relational algebra operators. Now we shall see how we can apply those operators on the relations which are given here. So this is a company database with employees working in departments, and departments are controlling certain projects and the employees work on certain projects for certain number of hours. So this being the data given, we need to see how we can write relational algebraic expressions to answer few of the end user queries. Let us consider unary operators, namely select and so we'll consider only those queries wherein only one relation is involved at a time. For example, if I want to find all the employees who are drawing more than, let us say, 60,000 salary, so how would I write that expression? So you need to write select from the employee table where salary greater than 60,000. And if you want to project out certain columns, like for example, I want only the first name and last name of the employee, then you need to project out those columns and put it in another relation R. So this will do a horizontal selection of the rows in the employee table. Similarly, if I want to get all employees who are working in department number 3, so you would write it like this: select where department number equal to 3 from the relation employee, and you want only the first name and last name, and you can store in a relation Q. So this is all employees of department equal to 3. This is all employees drawing more than 60,000 salary, right? So it is pretty simple to express the end user data requirements. When they want to extract some useful information, you need to apply select and project operators in the order that is shown in the expressions here. Now the more so now let's see how we can use the binary operators, namely the join operator, to extract data from more than one table and project out the columns that we need. For example, I want to find all employees who are working in, let us say, sales department. Now we know that employee information is in employee table and department name is in department table. So we need to join the two tables before I do any selection. So I would do employee join department. Now the joining column is the foreign key primary combination. Let's say you have department number in employee and department number in department. So the match is made and you will get employees department wise. Now we want only those employees who are working in sales department. So here you can say D name equal to sales, and you want to project out the first name, last name, maybe department name. And if you want to rename these columns, you can rename with first FN as first name, LN as last name, and department name as T name as department name, like that. So this is a rename operator which only changes the column names and gives you a new relation R. And if required, you can put a bracket here to indicate that the join must be done first before I do any select or project operations. All right. So these are some of the queries that you can see. Now the next one is get me all employees who are working on projects controlled by department number 3. Now here we need to select only those projects which are controlled by department number 3. So I would do a select operation where department number equal to 3 on project relation, and this is related to works on. So when you join works on with project number combination, this will give you all people who are working on projects controlled by department number 5. Now we need to uh, join this with employee table because we want employee names. So this will contain all the columns of employee, works on, and project with duplicate columns suppressed, and then we have to project out first name, last name, and maybe project number. So we will get only those employees and the projects on which I are working, and those projects are controlled by department number 5. So this should be department number TNO equal to 3. Alright. So this is how we can do the joining. Similarly, if I want to find all the manager names along with their department name. So we want manager name and department name in the output. So we need to first join employee with department. However, this time the joining attribute should be ESSN equal to NGRSSN because we want managers only. Okay, so once you get this, now you can project out the D name, F name, and L name. So you get all the managers' names along with their department names in relation. So you can write queries for variety of things like this. So for instance, you can find the find all projects on which one Mr. John Smith is working. Now first thing is you need to find out the ESSN of John Smith. So ESSN of John Smith. So you need to do a select here. First name is John and last name is Smith. This you will get from employee table. You can call it as Smith SSN. Now we need to find out whether he is a worker or not and his project. So we need to join Smith SSN with works on. So we'll get all the projects on with John Smith is working. So you can project out the ESSN and project number. So this is all projects of John Smith. Now we need to find out all those projects on which John Smith is working. So you should take project of ESSN. So you need to take only the project numbers here. So all project numbers of John Smith. You should project out ESSN and project number from works on. So this will give you all employees who are working on various projects. And if I divide this by all projects of John Smith, then you get only those projects on which John Smith is working, on all the projects on which John Smith is working. Okay. Uh, okay, I made a mistake here. This should be all employees. Find all employees who are working on all projects on which one Mr. John Smith is working. So this I made a mistake. So you need to find out the result using the division operator. Okay, so you need to project out only the ESSN here. So when you do the division, you don't have to project out anything. You will obviously get the result as the ESSN, and this you can join to get the all employees who are working on all the projects on which John Smith is working. So you can just project out first name and last name. So this is the final result. So we need to be very careful while you formulate the relational expressions, especially when you are doing division operation. You should really know exactly what you are doing. Okay. So we have equijoin, theta join, they're all more or less similar. But what comes next is the aggregate functions, which we have discussed last time, aggregate functions, where you want to find out the average, maximum, minimum, then total count, then sum. For example, if I want to find out department-wise average salary, so then I would write like this. This is the grouping attribute. Then you want department-wise average salary. So average salary should go here, and then the relation employee must come here. So this will give you department-wise average salary. Similarly, if you wanted department-wise maximum salary, you would have written like this. Max salary. Okay. So these are some of the things we should be aware of. So what we saw is the use of rename operator, select operator, project operator, the join operator, okay, then the division operator, then the aggregate function. Of course, we have not looked at union, intersection, difference, and all these, but they can also be explored if you have queries wherein an employee is working on project 5 or who is a manager of the department, then you have to find who's very going to take a union. Okay. So in the other case, intersection when you want employee present in more than one scenario. So and operator you can use. Difference is when you know that employees who do not have dependents. Okay. So if you know employee with the dependent, then you have the employee table, and if you take the difference, you get employees those who don't have dependents. So difference operator can be exercised like that. Of course, you have equijoin, left outer join, right outer join, and those things. So those also can be explored in a similar way. Okay. Thanks for watching, and I'll see you in the next video.